Dear learners, welcome again. So we are going into a video on scientific programming using Python, and this is as a part of unit 4 of this particular course. So let us enter into it. So, well, this course is basically those students who are having background in mathematics, physics and chemistry or other natural sciences, and many of the examples will be familiar to these readers. Okay, the rapidly increasing relevance of data science topic means that computation and scientific programming that will be of interest to a group of users like you, and this particular course has been developed keeping this only in mind. Now, you have already seen in kinematics equations like V is equal to U plus AT, correct? You have also seen the equations like S is equal to Vt, etc., right? What are these S, V, T, etc.? All of us know, right? S is the distance, V is the velocity, and T is the time or speed and time. Now, when we program for these formulas, we have to keep all these variables in our mind. So that is what is variables in mathematics is about. Such formulas are essential parts of most programs written for scientific applications. Almost all that you learned in your chemical reactions, kinematics, all set of formulas only, right? And each of these formulas we are having set of variables, and all those variables must be declared and initialized in order to be programmed. So they are also useful for introducing the concept of variables, which is a fundamental part of all these programming languages which we will be dealing with. This is first one, that is variables. Next comes the mathematical functions. Well, just now I told you that S is equal to Vt, correct? And now how this S is equal to Vt can be represented? If I am saying uniform velocity, that means V is constant, then I can write down S as a function of t which varies, correct? So we can define a function f with respect to time t for this particular distance s. So such calculations will be required, and there may be arguments to these functions that may also be required. So arguments to Python functions can be any Python object including another function. So we'll be dealing with these Python objects in detail in the form of classes. This functionality is quite useful for many scientific applications where we need to define mathematical functions that operate on or make use of another mathematical function. So they are all interrelated with each other. One will be calling the other, and all are part of one class, and from those class we can instantiate some objects. So that is the understanding over here. So first one, we learned variables in mathematical formulas. Those mathematical formulas can be defined in the form of mathematical functions, and for those functions we will be using the concept of classes and objects in Python, right? Then next comes the most important one, vector. Suppose I am dealing with electrons, right? I have a mass of the electrons, I have number of rotations per unit time, I have the charge of the electrons. All these what I am telling about electrons form a vector. Okay, that means all those features that I am collecting related to the electrons form the feature vector for me. And vectors are so useful and common in scientific programming that a special data structure by name numpy is used in Python, which we will be using in our codes. Fine. Then comes data files. Well, I told you about the feature vectors per particular electron. If I give you for all the elements that we are having in the periodic table, and we just hold all the data for each one of them, then that gives rise to a data file, and those data files are very much in use in this scientific computation. So scientific data are often available in files, and reading and processing data from files have always been important task in programming. So that is where we will be using Python to load that data and do various tasks on it. Fine. Then comes the most crucial thing, data visualization. Well, merely coding won't do. What exactly is happening over there, we should visualize. And for scientific visualization, we use a library or package called matplotlib, which we will be using in our labs, mostly from the module pyplot, to plot curves and create animations of the curves that change over time. That is what is our understanding is about. And to produce professional looking plots, such as in a presentation, master thesis, or scientific report, we will be using all these things in our lab sessions. Fine. Then comes the differentiation and integration, for which this module, this particular unit has been generated. So common tasks in scientific computing such as differentiation integration can be carried out with large variety of numerical methods. A few of them we will be learning in this particular unit for your understanding. Many such methods are closely related and can be easily grouped into families of methods that are very suitable for implementation in a class hierarchy. Basically, we are dealing with classes over there. That is the understanding, right? So with this all, we are entering into the topic, that is Python implementation for calculus in mathematics.